My name is Wendy Philman, and I had the question on how lactate is generated, how it is cleared, what its impact on exercise and performance is, and to provide some examples of how it is beneficial. So basically, lactate is generated when pyruvate, an end product of glycolysis, is joined with two hydrogen ions from NADH and H+. This process is assisted by LDH, or lactate dehydrogenase enzyme. I thought this could serve as a helpful visual diagram in that we start with pyruvate with the help of LDH, or lactate dehydrogenase. You have an NADH and an H+ ion, and they are converted into an NAD+, an H+, and lactate. So this is kind of like that process happening at the end of anaerobic glycolysis. And this formation of lactate is what helps to prevent end product inhibition. So basically, when glycolysis is happening too much or too quickly, excess pyruvate is created. And that excess pyruvate can act as a negative inhibitor pathway and slow down metabolism. So lactate is basically the system our body uses to keep metabolism running high even when you are making too much pyruvate. So that excess pyruvate is converted into lactate with the help of LDH and an NADH and an H+ ion. In this way, lactate is really beneficial because it allows our bodies to run at high metabolisms and continue to produce ATP and energy when we need it most. But the primary impact lactate has on exercise and performance is that it can be used as fuel by skeletal muscles and the heart. Lactate will be converted into acetyl-CoA and enter the Krebs cycle for ATP production. Another way in which lactate can be really beneficial is that it's actually preferred by three major organs. So as I just mentioned, lactate can be used by skeletal muscle and the heart. The heart actually prefers lactate to glucose and pyruvate, which is kind of surprising. And the brain also prefers lactate as an energy source over glucose. And lastly, the liver can convert lactate into glucose for the completion of the Cori cycle. On the other hand, lactate can be very detrimental to exercise, specifically if you are an unfit person, in that as an untrained individual, you're going to be relying on anaerobic metabolism for longer periods of time. That would include ATP PCR and also anaerobic glycolysis. And the end product of anaerobic glycolysis is lactate. So as an unfit individual, you're going to take longer to get to that steady state. I'll show a diagram for this later. You are going to accumulate lactate more than someone that is more highly trained or in a more fit state. So you are going to be prone to exercise intolerance, and it's going to be very uncomfortable to get to that steady state compared to if you were a fit person. I apologize for this very mediocre graph, but on the y-axis we have VO2 in liters per minute, and on the x-axis you have time. So as you can see, these two people are both at rest, and that is the moment when they immediately start exercising. This fit person has a much steeper slope of getting to that flat steady state, whereas the unfit person has a much more gradual slope, taking a lot longer, as you can see, to get to that flattened out plateau, which is the steady state. So this period of time for this unfit person, they're relying on anaerobic processes and taking longer to predominantly use aerobic processes, whereas that fit person is getting to aerobic processes a lot faster. And the point of me showing you this graph is that just to kind of summarize why buildup of lactate is so uncomfortable and such a detriment to someone that is trying to get into an exercise regimen. So basically, to summarize what I just said, how well you're able to use the lactate that is built up, or how long into exercise you go before switching to aerobic processes, can be indicative of your physiological fitness. And the way that lactate is cleared is that it can be oxidized in fast twitch muscle fibers, or it can be transported to slow twitch muscle fibers for oxidation by a lactate transporter. On a more practical application level, light exercise can also help to diminish lactate accumulation and can help to clear out that lactate. I'm going to borrow from a figure in our textbook that I think very helpfully demonstrates this concept that exercise is an aid in removing lactate. So on the x-axis, as you can see, we have recovery time, and then on the y-axis, we have that blood lactate concentration. I wanted to make sure I had that correctly. So that blue line, you can see that there's no exercise, and then that more turquoise line is light exercise. So as you can see, that percentage of like lactate accumulating in the blood diminishes a lot more quickly with just light exercise. So if you have an athlete that has just done a like long duration submaximal period of exercise, the best thing they can do is to work out in a very small increment at a low intensity for just a little bit of time after their workout.